This is chapter 15 that deals with the autonomic nervous system. There's two divisions of the autonomic nervous system. There's the sympathetic division, which is commonly referred to as your fight or flight. And then there's the parasympathetic division, which is rest and digest. So under most normal conditions, it's usually the parasympathetic division that's turned on. And then when there's some type of a threat, a very serious threat, could be life and death, that the body recognizes, oh, there's this crisis, then the sympathetic division will be activated. The autonomic nervous system is going to be controlling your cardiac and smooth muscles and also glandular tissue. And so this is under involuntary control. Your cardiac and smooth muscles, remember, involuntary muscles. So you don't have conscious control over this. This is different than what you saw with the somatic nervous system, which is under voluntary control, and that was your skeletal muscles. The sympathetic division, I know your book goes into a lot of detail, but we'll keep this short, sweet, and simple. The sympathetic division, what you're going to see, there is a crisis. You perceive there is a crisis, could be life and death, very serious threat. And so what's going to happen in response, your body is going to increase your heart rate. It increases your breathing rate. It's going to increase the blood flow to the skeletal muscles. How? By what it's going to do with the blood vessels is it will dilate them. So you have increased blood flow going to just those to the skeletal muscles. You're going to increase your production of sweat. So you're going to start sweating on your forehead. Your palms are going to get sweaty. Your pupils are going to dilate, so you increase more light coming into the eyes. And your sensory awareness increases. You are aware of every sound, everything around you. You're very much aware. Now, at the same time, you're going to decrease the blood flow to the digestive organs, the urinary organs, and the reproductive organs. How do you decrease the blood flow? You're going to constrict. Make the diameter smaller of those blood vessels. You don't want to stop the blood flow because that's going to kill those organs, but you just decrease the amount. Why is all this happening? Stop and think about it for a minute. Fight or flight. There's a threat. You need to respond to this threat, which means you either need to fight or you need to run and get out of there now. So if there's a threat, if you're going to stay and fight, or if you're going to run, you have to be very aware of your surroundings to know which way to run. Or if you're going to fight, say somebody, which way is the individual coming from? Do they have any friends with them? Are you trapped into a corner? Do you need to have an escape route? So that's why you become very much aware of all your surroundings. Why do you increase sweat? Well, you're going to be increasing the amount of skeletal muscle contraction. That increases heat, so you need to be able to dissipate that heat. And also, like sweaty hands, you might not really think about it this way, but it helps you to grip stronger onto something if you need to pick up something to use as, say, a weapon to hit someone. Why are you increasing the breathing rate? Because if you are going to be using more of the skeletal muscles for either fighting or running, that requires a lot of, remember, for muscle contraction, it requires ATP. What do you need to generate ATP? You need oxygen. So you need to increase the breathing rate to get oxygen down to those skeletal muscles so you can make more ATP so you can continue the muscle contraction. How do you get the oxygen to the muscles? Remember, that's the blood is going to carry it. So that's why the heart rate has to increase. Get that blood going, or the oxygen going from the lungs to the muscles. So every aspect of this plays a role working together so that you can have increased muscle contraction, increased awareness of your surroundings. Why do you decrease the amount of blood flow to some of these other organs? Well, let's say you just ate supper. If you're in a life and death situation, it doesn't matter whether you digest that donut you just ate. You might be dead in 5 minutes if you don't act accordingly. So, like I said, you're not going to completely shut off the blood flow, but you are going to decrease the amount to where you need it. So the body's constantly adjusting depending on the needs. So sympathetic, fight or flight. The parasympathetic is going to be the reverse. So under normal conditions, you have increased blood flow to those digestive organs. You're just sitting around chilling. Go ahead and digest that donut that you just had. Keep blood flowing to the urinary organs. Let those kidneys filter out everything that you just ate. Decrease the heart rate. You don't need to have a fast running heart right now. You don't need to have extra. You need oxygen going to your skeletal muscles just for maintenance, but you don't need to have this huge increase. So keep your breathing rate normal. Keep the blood flow to skeletal muscles normal. You don't have to have sweaty palms to be eating your donut and just sitting or just reading. Hopefully studying A&P is not a stressful situation for you. You don't need to have the sweaty palms picking up the book. You don't need to have this extrasensory awareness. Rest and relax. Just sit and chill out. That's the parasympathetic division. The autonomic reflex arc, this is going to target your cardiac muscles, smooth muscles, and glandular tissue. It's very similar to what you've seen before. You still have a receptor, you still have sensory neurons. Usually there's an inner neuron, not always, but usually there is. There's still a motor neuron, but the effector is different. As we said earlier, with the somatic reflex arcs, it's always going to be a skeletal muscle. With the autonomic nervous system, the effector is going to be different, whether it's targeting the cardiac muscle or glands, etc. That's where the difference is going to be. Referred pain. Oftentimes, some of the visceral senses, they're not consciously perceived. You're not aware that the aorta is stretching as your blood pressure increases. You don't have to be aware of that. The body just responds to it. Sometimes you do become consciously aware of certain sensations. But what we have found is that oftentimes it's not in the area where it's actually occurring. And that's what we call referred pain. You actually feel the pain in a different area. This whole idea of referred pain, we know that it happens. We know where in the body you may feel the pain, and knowing that that's not where the pain actually is. It's not completely understood why this happened. One of the more accepted theories right now is that we think it happens because you have the somatic sensory fibers. So fibers coming from, say, the muscles in that area, from the somatic nervous system. They are entering in the spinal cord at the same spot as to where the visceral fibers are coming in. So the nerves are coming from the same area, in that the brain is misinterpreting where that sensation is coming from. So in other words, it's the sensory fibers coming from, say, the left arm, enter the spinal cord, same area where some of the nerves coming from the heart. And so in the brain, it's picking up, oh, there's pain coming from these nerves, but they're both coming in at the same spot, so it confuses sometimes. Is it coming from the left arm, or is it actually coming from the heart? Like I say, it's not well understood. That's one of the main theories right now. This diagram is showing different areas of, like I said, we know where you may feel some of the referred pain. Probably one of the classic ones is with the heart, often the chest and down the left arm. The appendix is often felt in this range right over here. And so it may not be exactly where the organ is. One thing just to keep in mind with referred pain is that males and females do respond differently. One of the big things in studies that we are finding out is that pain that is associated with heart attack is very different in males than in females. We're not the same, and we don't feel things the same. The classic symptom of a heart attack, initially, was studied so much with males, where they talk about the chest pain and the chest pressure. It feels like an elephant sitting on your chest, and shortness of breath. What we have found is that in females, they may have shortness of breath, but instead of feeling that severe chest pain and pressure, oftentimes in females, it's felt more as back pain. And the other thing is that refer pain, as I just said, down the left arm, that is more indicative or found more often in males. In females, they often don't feel that. So just be aware there are the differences there. You have different reflexes with the autonomic nervous system. We talk about short versus long reflexes. The difference between it is the long reflex is going to include the central nervous system. The short reflex bypasses it. It doesn't involve the central nervous system. The sensory neuron is going to come, and instead of sending that information to an inner neuron that's located in the spine or the brain, instead it is going to directly synapse or connect to a neuron that then stimulates the effector. So it's like you bypass a step. And that is seen in this diagram right here. So in the upper picture is a long reflex. You have your sensation, so your receptor is stimulated, which then sends the information down the sensory neuron, which goes to the spinal cord. It is going to activate or stimulate the inner neuron, which then activates the motor neuron, which comes out and finally activates the effector. With a short reflex, you cut this step out right here. So instead, you have the stimulus. It stimulates the sensory neuron, comes down. The sensory neuron directly, right here, stimulates this motor, which in this case we call the peripheral ganglion. You bypass the central nervous system. That's just the difference between them.